All right, so we're going to look at yet another polar equation. This one's a little bit different. In the previous video, you saw we graphed 4 sine 3 theta. So we're going to see what happens when we change the angle to 2. Now, based on what you saw in the last video, you would think that 3 theta would give us, or I'm sorry, you would think that 2 theta gave us 2 petals because 3 theta gave us 3 petals. Well, let's see what happens here. So taking the same approach as last time, I'm going to make sure that 2 theta is equal to all of those angles, the special ones, going around one revolution. And I just have a feeling that we're going to have to go around another. So cosine of those angles, we know cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is -1, then back up to 0 and back up to 1. And that corresponds to actual angles of 0, pi over 4, pi over 2, 3 pi over 4, and pi. So let's see what happens here. So multiplying all of those by 5, we have 5, 0, -5, 0, 5. So let's see what's happening here on the grid. So when theta equals 0, we're at r equals 5, which means the circle that kind of looks different than the others. Must have known what I was doing when I made that. Then at pi over 4, we're back to 0. So just drawing a little line there for pi over 4. So by the time we get from theta going from 0 to pi over 4, we go from 5 down to 0. So that means we're kind of looking at something like that. Okay? Theta decreasing from 5 to, or I'm sorry, r decreasing from 5 down to 0. Then at pi over 2, we're facing r equals -5, which means, again, I want to face this way, but I'm going 5 units to the negative. Now, keeping that pattern going, you know, we're talking about theta equals pi over 3, 5 pi over 12. So we're going to end up over here, you know, because we're normally going to have a point up here, but it's going to get reflected down here. So by -5, we are there. Now when theta equals 3 pi over 4, we're back to 0. So what does that mean? Well, our angle is up here, which means a -r would be down here. So that means we're coming back up. And by theta equals pi, we're back to an r value of 5. And again, we're talking about positive values of r now, so that means that whatever quadrant I'm in is whatever quadrant the points are in, so we're going to go this way. Now, it looks like we haven't completed the picture yet because we didn't go back to where we started from. So, I'm going to make another cycle. So I'm going to say 5 pi over, 2, and then 3 pi, and then 7 pi over 2, and then 4 pi. So then dividing everything by 2 to get the actual theta, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. So it looks like we have a full revolution happening here. And then these values are going to repeat themselves again. So we have 1, 0, -1, 0. Then we have 1, 0, -1, 0. And then we end up at 1, which means this is a 0, this is a -5, this is a 0, this is a 5. So we'll see what happens when we get there. So we've already gone to here. So then we're going back to 0. And again, we're going from theta equals pi to 5 pi over 4, which means we're talking about positive r values, and we're talking about this quadrant right here. So that means we're not reflecting at all. We're heading back to 0. Okay? Then at theta equals 3 pi over 2, now again, 3 pi over 2 means I want to face this way, but r being -5 means I'm going to face this way. So we're at this point, and again, we're hitting it this way. All right? So then we're back to 0. And then now r is going from 0 to 5, so we're talking about positive r values, which means whatever way our angle is facing, that's the way r is. We're coming back to here, and then we're back to where we started from. Weird, huh? So this has 4 petals, So cosine 2 theta has 4 petals. Sine of 2 theta also would as well. Okay, so cosine and sine kind of work in the same way. The petals would just be oriented differently. So if you have sine of n theta or cosine of n theta, where n is even, you're going to have 2n petals. So I urge you, go to Desmos, try it for, 2 theta, 4 theta, 6 theta, whatever, and you'll notice that you have double as many petals. Kinda cool, huh? Okay, come back for another video. We'll talk about one last example, and then we'll wrap this up.